Okay, so I think it's time here to get started. So first of all, thank you so much for all of you who has come here to my session. So my session is on affective computing. How can we use AI in order to bring humans and machines closer together through emotions? But before we start off this, we want to thank our sponsors. So we want to thank our main event sponsor, which is Microsoft, and then our platinum sponsors that you can see here on this slide. And then we also have a number of gold sponsors that we would also like to thank. So we'd like to thank all of our sponsors because without them, an event like this wouldn't be possible to do. So thank you so much for supporting us. Now, a couple of background information about me. So as I said, my name is Håkan Silfvernagel. I work as a manager for AI and big data at a Norwegian consultancy company called Miles. And my background is in human-machine interaction for process automation and robotics. And I also have a master's degree in electrical engineering and also a master's degree in behavior science. So I'm sort of interested both in the technology aspect of things, but also in sort of the software side of things in psychology and behavior science. And if you want to reach me, I'm quite active on LinkedIn, so you can reach me on this link that you can see here, or you can also reach me on Twitter at my handle, Agrevlis. And talking about active, I'm quite active in the local user community in Oslo. So I'm the chairman of the Norwegian .NET user group, which is focusing on Microsoft and .NET related technologies. I'm also part of the organizers for Oslo AI. So Oslo AI is a meetup that is focused on making AI understandable for the local community. So what is sort of the benefits of using AI? And I'm also running a virtual user group, the Azure User Group Sweden, together with Jonah Anderson, who is an Azure MVP in Sweden. And I'm also founded an online AI school called AI42, together with two other AI MVPs, eParty and Gosia Borseka. And if there is time allowed, then I will talk a little bit more about this AI school. But basically, our goal is to be able to provide information about AI to everyone on this planet. I'm a Microsoft MVP in AI, and I'm also a Microsoft Certified Trainer. But I think that's enough about me. So now the topic here for today is affective computing. So what is affective computing? Well, one way to see it is that it is the software side about AI. So a little bit longer definition is that this is the study and the development of systems and devices that can recognize, interpret, process, and simulate human effects. So that means how can we actually understand our emotions in our different systems and devices that we produce. But in order for us to understand this a little bit more in depth, then we need to understand what is an emotion. So now I'm going to cover a little bit about what we can say about emotions from psychology. So from psychology, we can distinguish here between three different things. So first is emotions. So an emotion is a fast automatic response. It's temporary, and it also react to stressors. So emotions, as we will see further on in the presentations, emotions are actually common to all people. And then we have what we call feelings. So feelings, with a feeling, then you need to involve your cognitive abilities. So you need to be aware of how the environment looks like, and it involves a thought process, and it's also much more long-lasting. And then we have something that we call mood and effect. So this is if you combine feelings and emotion together, and this is a much more complex phenomena, and it could also be long-lasting. So now I'm going to cover some of the major theories here from around the 1800s up to now from psychology. So if we start out here from the 1880s, we have something called the James Slang theory of emotion. So what they said was that first we see something external, we get an external stimuli, and that leads to physiological reaction. And this reaction is dependent on how we can interpret this physiological reaction. So for example, imagine you're out in the wood and then you see a grizzly bear. You will have a physiological reaction. You will start to tremble. Maybe your heart will start to race. And according to these researchers, James Slang, they say that we will interpret this physiological response, and then we'll conclude that we are frightened. So that means that you are not trembling because you're frightened, but you feel frightened because you're trembling. But if we think a little bit more about this, this is probably not the right interpretation here, because that means that for all emotions, then we need to first feel, a physiological reaction, and that's not the way it actually works. So these researchers got challenged by another set of researchers here, Cannon Bird, and they said that we feel emotions and this physiological response at the same time. So in the brain, part of our brain sends a signal which will result in a physiological response. So for example, you see a snake, and then you're afraid and you begin to tremble. And the thing is that people can experience the same physiological response to different emotions. So an example of this is sweating, and heartbeat, and respiration. They are the same, regardless if you feel fear or excitement or even anger. If we fast forward here to the 1960s, then we got something called the two-factor theory of emotion, or the cognitive theory of emotion. So here they're focusing on the interaction between two factors, the physiological response and also our cognitive labeling of that response. So an example here is, imagine you're alone in a parking lot, and all of a sudden you see a stranger walking towards you. So what will happen is you will recognize that you see a stranger approaching you, and then your heartbeat will start to race and you tremble, and this rapid heart rate and trembling are caused by fear. So here you involve your cognitive abilities. You do something that is called a cognitive labeling, and then you can conclude through this cognitive labeling that you're frightened. And then one of the more modern theories is by Lazarus. This is called the cognitive appraisal theory. So by appraisal, that basically means that you start to think about what does this actually mean. So first you have a primary cognitive appraisal. So you ask yourself, what does this mean? It could mean that maybe what is happening around me is not important, or maybe this is a good thing, or it could be that this is very stressful. And then after this primary appraisal, you do secondary appraisal. And it could be either a positive appraisal. You can decide that I can actually do this if I do my best. Or if this fails, I will just try another method or another approach. But you could also have a negative appraisal. Then you say, I can't do this. I know I will fail. I won't even try because my chances are too low. So an example again here, when you were out in the woods and you see a bear, then you can have a primary appraisal that this is very stressful. And then a secondary appraisal, but I can actually escape. So now when we know a little bit more about what an emotion is from psychology, then we can talk about how can we actually measure emotions. So we need to go back here to the late 1800s. Then we had Charles Darwin. He wrote a book called The Expression of the Emotions in Man and Animals. And in this book, he claimed that emotions are universal across the human species. And he also claimed that these emotions had an evolutionary history. And that was quite a bold statement here in the 1800s. But as we'll see, he was actually right. And then we move forward to the 1860s. We had a French physician called Duchenne. So what he did was that he had his patient, and he used two electrodes that he had a small current into the facial muscles, so he could make the facial muscles react. So he did that on his patients, and he documented it through photographs. And then he said that he could actually distinguish between 60 different discrete emotions. And this will be important here now, as we see in the common slides here, because in 100 years later, then we have an American psychologist called Paul Ekman. He was studying facial expressions and emotions. So in order to do that, he traveled to Papua New Guinea to study facial expressions. And he selected an isolated tribe, and he found evidence that facial expressions and emotions are actually universal. The same thing that Charles Darwin had said here some 100 years before. And what he did, in addition to that, he also made something that we call facial atlas, or an atlas of human facial expressions. So as you can see here on this slide here, you can see what we call micro expressions. So these are small muscles in our face that can react, and then it can reveal actually what type of emotions are we experiencing. So this is used in behavior studies now, and it's a very valuable tool here. And he also found out that actually these emotions are universal across different cultures. So how can we do then if we want to detect emotions? And I should also say that in this picture here you can see what we can call the universal emotions here, which are a little bit depending on what literature you study, but between 9 and 11. But there are 3 different main ways that we can do emotion detection. So the first one is through facial and bodily expressions. So that's just through observation. And the second one is through speech analysis. So you can analyze the tone, the intonation, the pulsation, and the rhythm, or you can use physiology-based measures. You can measure the EEG or the heart rate or the skin conductance in order to detect what kind of emotion a person is experiencing. So now when we're going through a little bit about what was this an emotion, how can we measure emotions, then we can dive into the field of affective computing. So affective computing started out by a researcher at the MIT Media Lab called Rosalind Picard. She wrote a book in the 1990s, and by doing this, she started a whole new field of research. So by now, it has its own IEEE proceedings and its international research groups all over the world. But at that time, in the middle of the 90s, she said that it was very difficult to get funding for this because a lot of people said that this is, very futuristic and maybe sci-fi oriented. But that was because of the standard of the PC systems at that time. Because the thing that she was promoting or suggesting was that we should be able to use sensors, we should be able to use cameras and microphones, and we should be able to use machine learning in order to do speech recognition, gesture recognition, image recognition. And by doing so, we can actually use the machines in order to understand us as a user, what kind of emotions are we experiencing. So, but what has happened now since the 1990s and through today is that we've had a very technological evolution here. So, for example, we have smart sensors that we can use that can give us a lot of data that we will need to have in order to do these different types of machine learning that we wanted to do. And we also have big data solutions running in the cloud, so we can do transformation of data, and we can also do machine learning also in the cloud, so that we as software developers, we can just use these algorithms through an API call. So one example of this is something called the facial detection API. So I should first preface this by saying that all of the larger cloud providers has similar types of services. But this is an example here from Microsoft. It's part of the cognitive services. So what we have here is we have something called the emotion API, where you can analyze pictures, and you will get back an emotion profile, as you can see here on this slide here. But we also have, for example, Amazon has something called Amazon Recognition. IBM has something they call the Emotion Analysis API. And also we have different services to analyze both the content of images and videos, but also of speech and text. So I was thinking I will just show you quickly here how this is actually working. So let me switch over here to the Azure portal. So now we're inside the Azure portal, and then we can search. For face. And then we get here a face resource here that we can create. And then you just initiate or initialize your face resource here through defining what subscription, which resource group, and which region, and so on, and which pricing tier you want to use. And after you've done that, and after they have created the facial resource for you, what you will get is a test console here. So in this case, test console for the facial API, you can you can decide here what is the research name, and you can decide that you want to be able to return facial attributes, the emotion attributes. So what it will do is will analyze a picture that you give to it, and then it will come back with an estimation of what is the emotion that the people in the image is feeling here. So basically what you do is you just need, so I have some pictures here, for example this picture here. So this is a boy that looks quite surprised. So if we take that as an input to our API, so this is the emotion detection 1 picture, and then we just make an API call. And if we scroll down here, what we get here is first a face rectangle which decides where is actually our face in our picture. And then we get the facial attributes, we get the motion, and then we get an estimation here, a percentile estimation that, for example, it says that this person in the picture is experiencing surprise with 80%. For example, we can also change to another picture. So I have another picture of a woman that looks like this, and then we can change here to another picture and can send this. So then if we go through here, again we get the face rectangle, and then we can see here that 89.9% she's experiencing disgust. It actually also works if you have multiple pictures, if you have multiple people in your picture. So for example here we have a man and a child. So if we submit this to our API, if we change this thing here, then we send this, and as you can see here, then we actually get both two rectangles here where the different faces are, and also two attributes, emotional attributes. So we can see the first one, it's surprise with 99.1%, and then we can also see here that for the second one is more neutral with 0.09%. So that's just an example here. Let me go back here to my presentation. So now when we've seen that, then we can go through here to one moment there. Yeah, then we can go through some application scenarios here for what you can use affective computing to. So one of them can be within retail. So you can imagine you have a retail store and it's equipped with web cameras so that you can decide what kind of emotions our customer experiencing. So then the staff in the store can use this information in order to both enhance their services and also give their customers a much better experience in the store. And then we also have within medical, so in medical you can use both these physiological measures to determine the state of the patient. And then by doing this, you can reduce both the stress, among other things, and the medical team can be able to respond much quicker to the needs of this patient. And you also have, in the education field, you can imagine that you have a class and you also have web cameras here, so you can detect if people are starting to look boring, then you can adjust your teaching style according to what your students are experiencing. And actually one big problem here in our Western world is that we have a growing population of elderly people, but we don't have enough people to take care of them. So one of these countries where this is a big problem is Japan. So in Japan, what they have tried out is they've tried out robots that will use both facial recognition, speech and tone evaluation, and also these physiological measures to adjust their behavior towards the elderly people. So now I would like to just present what is actually in the front line here. So one of the companies that is in the front line is called Affectiva. So Affectiva also stems out of the MIT Media Lab, and what they have is they say that they have the world's largest emotion database. So they have 6 million faces across 7 different countries. So what they do is they offer an emotion API that we can use, an emotion SDK and an API that developers can use so that they can integrate this technology into their own products. So some example of use cases where this can be used is, for example, you can have virtual assistants that can determine the emotion of the user and then adjust their answers according to that. You can also think about a much more personal transportation experience. So let's say you have a self-driving car, and the self-driving car can detect what is the emotional state of their passengers. So if they're in a good mood, it can turn on some funny music and go through the scenic route. But maybe if they're in a bad mood, it will just take the shortest path here between two different points. And it can also be used in advertising. So in advertising, it's really important to find out exactly at what time a person is experiencing an emotion, because then you can actually adjust your commercials so that you get the effect that you would like to have. So we can talk here about emotion as a service. So as I said, you can use it for facial analysis, but you can also use it for face and head tracking. And this has been used in the car industry. So then we can actually send out a signal, a warning sign, if we detect that the driver is getting drowsy, so he or she doesn't cause an accident. I would also like to introduce you to Pepper. So Pepper is a robot developed by the SoftBank Robotics, which is a Japanese company, and it is focusing on creating robots that can adapt to humans. So what Pepper does is he determines the emotions of the people around him, and then he is utilizing both voice and face recognition, as well as body movements. And he will respond by changing the content that you can see here on the tablet that is on his chest. So it's been used both in banks in Japan, in Nestlé cafes, and also in, as you can see here, in the railway stations in various places in Japan. And a fun fact about Pepper is that as of 2018, he is using the Affective API for emotion recognition that we could see here just on the previous slide. So now we'll talk a little bit about that. I would also like to touch here about artificial general intelligence. So we say that we have an artificial general intelligence if we have a machine that can perform any intellectual task that a human can do. So that is very different from what we have now. So what we have now we call narrow intelligence. So this is if we have a very specific problem where we can use machine learning in order to solve this problem or a reasoning task. So we have some operation definitions here for artificial general intelligence, and we have some tests here. So maybe the most famous test is called the Turing test. So it was first described in 1950 by Alan Turing. And so what it says here that a program, so there's a competition here. So a program will win $1 million if it can fool half of a panel of judges into thinking that it's actually a human, while it's interacting with them both in a free-form conversation for 30 minutes and also interpreting audio-visual input. So that's quite heavy demand. So we're not anywhere near that today. We also have something called the coffee test. So the coffee test here, you can imagine that you have an AI that goes into an average American house, and it needs to be able to figure out how can it actually make a cup of coffee. So this includes both identifying where is the coffee machine and figuring out what does the different buttons on the coffee machine do. And in the end, it also needs to be able to find the coffee in the cabinet and so on. And we also have something called the robot college test. So this is when a robot can actually enroll in a human university and take classes in the same way as a human can do, and also get a degree. And we also have something called the employment test. And this is when machines finally can exhibit true human intelligence, so that they will be able to do many of the things that us humans are able to do. But I know that a lot of people, they can feel a little bit frightened here about when we talk about artificial intelligence. So let's think for a moment here, what does this have in place for the future? Is it a threat or is it a hope? So let's have a look at what some different famous people have said here during the history. So first off, we have Elon Musk. So what he said here, he said that with artificial intelligence, we're summoning the demon. He said that AI is our biggest existential threat. And this was in 2014. And we also have Stephen Hawking. He said that the development of full artificial intelligence could spell the end of the human race. it would take off on its own and redesign itself at an ever-increasing rate. And humans who are limited by slow biological evolution couldn't compete and would be superseded. This is Marvin Minsky. He's called the father of machine learning, or the father of AI. He said that once the computers get controlled, we might never get it back. We should survive at the sufferance, and if we're lucky, they might keep us as pets. So he said this in the 1970s. And we also have some two other researchers in the AI community, Alan Newell and Herbert Simon. They said that something called the symbol system modeling human problem solving is the answer. And we better alert the people. And this was in the 1970s, but they didn't really need to alert the people. Symbol systems modeling didn't cause any world crisis here. But now, much more recently, we have a researcher from MIT called Max Tegmark. So what he did, he performed a survey across the leading researchers in AI. And he was asking them two things here. So both if this superhuman AI appears, will it be a good thing or will it be a bad thing? And also, in which time frame are we looking here at this superhuman AI? And as you can see here, on the x-axis is if it's a bad or good thing, and on the y-axis is sort of the time here. And we can divide the research community into different sort of groups here. So first of all, if you ask them, will this happen just in a couple of years? There's virtually nobody who believes that that will happen. Or will it happen between a few decades and maybe 100 years? Then you can divide them into three main groups. So you have the digital utopians, which believe that regardless, this will be a really good thing. And you also have something that we call the Luddites, and they say that this will definitely be a bad thing. And then you have people who are, somewhere in between here that we call the beneficial AI movement. And you also have technoskeptics. So the technoskeptics says that this will not happen in 100 years. Maybe it will happen in 300 years, or maybe it will never happen. So now another thing that is important here when we talk about AI is about AI and ethics. So there has been an experiment called the Moron Machine. So the Moron Machine is an experiment here where you get a situation. So one type of a situation could be this, that you get a situation where you have a self-driving car that is going towards a zebra crossing, and then you have some pedestrians crossing this zebra crossing. And then the question is, what should this self-driving car do? Should it prioritize humans or pets or the passengers in the car over the pedestrians, more lives or fewer lives, women over men, and so on. So this test has been taken by millions of people here. And we will have a look here at what some of the responses have been. And one interesting thing also to think about is, should the car actually take action or not? Maybe it can say that, this situation, I can't really decide what to do, so I'm giving over the steering wheel here to the humans. But what we can see here is that there is a cultural element into this. So you can see that countries that are much more individualistic are much more likely to spare the young people than the old. So for example, United Kingdom and United States versus Japan and China, which is much more group focused. And we can also see here, the same here with, they are much more likely to spare more lives, also from United Kingdom and United States versus China and Japan. And how do you want to spare pedestrians or passengers? Then we can also see here that there actually is cultural differences between countries like Japan and United Kingdom, or United States and China. So what is important here is to think that, if we as humans can't really decide on what is the moral or ethical right thing to do, then how can we then think that the software system that we have created, that should be able to give a moral perfect answer. So what is important for us to realize here is that it's heavily dependent both on where we have developed our machine learning algorithms, but also dependent on what kind of data has been used, who was developing it, how was it tested, and so on. So that brings us into something called FALERN here, which is a tool. So one of the challenges here when we work with AI is that AI has a tendency to treat people unfairly. So we can recognize here that fairness is something we call a socio-technical challenge. So there is both societal basis in the data sets that we're using, and we also have societal biases when we develop and deploy our machine learning algorithms. So some example where this has been a problem here is, for example, there was some company that developed an automated resume screening system where they found out that since women were underrepresented in tech, then it led to fewer employment opportunities for women. And we also have facial recognition systems that are not able to recognize people with a particular skin tone or skin color because it hasn't been trained on that type of data. And we also have problems with machine translation systems. For example, there are some languages which are gender neutral, like for example, Turkish. So if we translate a sentence here that he or she is a nurse, it will always come back to she is a nurse when you translate it over to English here, regardless of what it actually was in the beginning here. And you could also have image search. If you search for a CEO, for example, it will return just images of men. So we can also talk about two different situations here, one that we called a quality of service harm, and an example here is a voice recognition system that may fail to work as well for women as it does for men. And that's also a common problem with some of the more popular voice recognition devices that are out here on the market. And we also have something we can call allocation harm. So you can imagine a system for screening a loan or job application, and it might be much better at picking a good candidates among white participant or white men than among other groups. So then we can introduce here Fairlearn, which is actually an open source toolkit, but it is now also integrated into Azure Machine Learning. But it is still an open source toolkit that you can use regardless here. So this is an example here of a classification problem. So some people want to take a loan, and then the question is, would you be able to take this loan or not? And then what we want to decide here is we want to see how fair is our machine learning algorithm. So we decide what feature would we like to evaluate our model's fairness on. And this example, we take gender here as our feature. And then we say, how do we want to measure performance here? So we say that we want to have accuracy as a performance measure. So here is the probability of actually getting a loan here. So we can see that there is actually a disparity here on 12.5%. That is based on gender. So on average, you can see here that 16.4% will actually get the loan, but there is 21% of the male will get the loan, but only 6.35% of women. So we can see here that we say that there's a 15% disparity rate, and we should try to do something about it. So what we can use is we can use Fairlearn, and we can create a new model that we can train here using something called a fairness constraint. And in this case, we are using something called a demographic parity. And when we use this, then we will get a new selection rate, which is much more fair. So as you can see here on the picture, we get for male, it's 17%, and for female, 15.5%. So that's much more fairer than what we had here initially. And we can also compare our mitigated model with our original model and see how it has affected our accuracy, because that was our performance measure. And here we can compare it, and then we can see here that the accuracy has dropped here from 84.4% to 82.1%. So that's not so much, but we can see that this disparity has actually been reduced from 15% to 1.63%. So that's a very good result if you can take that accuracy reduction with a couple of percent, you will have reduced the disparity with a lot. And as I said, you will find this inside the Azure Machine Learning if you want to use that, or you can use it as an open source toolkit too. Now I'm about here to finish off my presentation here, so I just want to touch about something called collective intelligence. So collective intelligence is nothing new. It's been known for a long time that a group of people have a much higher probability of finding a great result than a set of individuals. But the question is, can we find like a single factor that can determine that we can call collective intelligence for when does this actually happen? So they've done a lot of studies around this to find this factor. So they found 3 different factors here in a study. So one of the factors is something called the average social perceptiveness. And that's a test that you can actually do yourself. So what it deals about is the ability to be able to read the emotion of another person just by observing the eyes of the person. So if you search on this, you can actually do this test yourself. And the second factor here is the participation in group conversation. So here they say that it's really important that everyone in the group needs to be able to speak their mind. You shouldn't have any people that are really dominant people in the groups here. And the third one is the participation of women in the group, because they found out the more women in the group, the more intelligent groups because of this social perceptiveness that I was just talking about. So for us, what this means is that for us as individuals, we need to be good at working together, we need to have good interpersonal skills, and we also need to have devices and systems that can understand our emotions. And this is the whole field here of affective computing. So I have some references here if you want to learn more about this topic. So first we have this book by Rosalind Picard called Affective Computing that started everything. So that's a good reference book to understand what is sort of the history and where does all of this come from. And then we also have the blueprint for effective computing here by Klaus Scherer and Tanja Bensinger. And we also have the Oxford Handbook of Effective Computing by Calvo, De Mello, Gratsch, and Kappas. So with that said, I would like to thank all of you here for coming to my session. And if you want to reach me, you can reach me either here on Twitter, on my handle, which is Agrevlis, or you can reach me on the email address that you can find here on the slide. And I will also be available here throughout the conference. So before we finish, we would once again like to thank all of our sponsors, our main event sponsor, Microsoft, our platinum sponsor, and all of our gold sponsor. But generally, all of the sponsors that are here, we would like to thank you so much for supporting us for creating this event. So thank you so much. And we also have time here for some questions too here. So we have a question here from the corner.
Yes, so I have a couple. So first of all, the face recognition. I think you've mentioned using it for identity. How would you handle the real-time response of it and privacy?
Yep.
Like, I mean, the biggest problem with this is obviously, how do you actually get your customers to agree that you're monitoring the facial expressions throughout shopping experience?
Yeah. So the question was, how can you actually take into account both the privacy of the participants and also how can you handle, the latency when you need to do this machine learning algorithm and you need to send a request here back and forth here. So first of all, I should say that many of these examples has been taken in countries such as China, for example, where they have a totally different set of rules. So I think what is important here for us is to realize that these are some of the things that are possible to do, but it's not always that we have things that are possible to do, which is actually a good thing to do. So then it's, I think what is important here is to realize that we can do this, but should we do it? So I think that's why it's very important to raise the awareness here of what AI can actually be used for. And then the second thing was about about the time here to make this call here. So what you can do here is you could imagine that maybe you're not sending all of this through the internet or through a mobile network. You could do this directly on the device, for example here. So there are different types of applications here, but I think there is a huge opportunity here for making machine learning right on the device.
Thank you.
And we also have we have one question here.
Thank you very much. That was fascinating presentation. Really interesting subject. In terms of the Japanese work that's being done in robotics, how advanced is that? Is it a study? Is it a pilot? Is it advancing at pace? Because obviously the global population demographic is probably similar to the UK. In that people are born with complex needs and a lot of people kind of picking up, people in the NHS, etc., the demands on services. So how is that playing out? Is that international study? Is there interest in that from different companies?
Yeah, so the question here was about this Japanese study here, or the experiments here with having robots helping out the elderly people due to this lack of younger people to take care of them, and also the recognition that maybe we have a similar situation here in the UK, and what is what has the experience been? As far as I know, this has actually been implemented large scale in Japan, so it's not just some individual tests or tryouts. But I'm not sure here if there's been any longitudinal studies or long-term studies of what it is. But probably I can probably see if I can find something out about that. Yes. Mm.
Fantastic work that's
mm.
it's really important because it's actually it's a reality, isn't it? Once it's out there, it's not something that we
Mm.
kind of just ignore it.
Yeah.
It becomes a thing around politics, as you
Yes.
say, in China, where
Yeah.
maybe some different rules and regulations, or
Mm.
it's how citizens decide themselves how advanced
Mm.
this will go, isn't it?
Yeah, so the comment here was about that it's also important here, also in this elderly people example here, to take into account that, maybe there are things that we can do, but maybe it's not, the right thing to do. And it's important to have a debate about this, maybe even before we start to introduce it, because, sometimes when you introduce a technology, then it can be quite difficult to scale it back, to reduce things. So it's much better to take things from the start here. And also have a comment here from.
Yeah, you were mentioning a lot about disparities between, for example, the loan, whether it was male or female. Wouldn't it not be possible to just completely omit that data from the actual training of the model? Like, why would it actually be necessary to input whether it's a male or a female into the data in the first place if it's causing such big disparities? Can I just totally remove it and take into account the actual factors that are important when making a loan application?
Yep. Yeah, so the question here, or the comment, was about this example that we had about this loan application that, we saw here that there was a disparity, gender-based disparity, but maybe why don't we just remove that feature or the gender from the data? But the thing is that, maybe we need this gender thing, we would like to use it for some other type of analysis, so that's the reason why we don't want to remove it. And this was just about gender. There could be other, could also be a disparity in age, for example, or in education. So this goes much further than only gender. So it's, disparity or unfairness in general. How can we actually do that? Because we know that that is actually a big problem when working with machine learning algorithms, that we will take with us the bias that we introduced even from the get-go when we started to collect our data. And how can we actually, what can we do to do that? So, in an ideal world, we would like to collect, so we have, about the same amount of data on everything, but we're not living in an ideal world here. So we need to try to find some way that we can mitigate these consequences. Yes. So do we have any more questions here? No? Okay, then I just wish you a continued good Scottish Summit. Thank you so much.